Hi, my name is Bashir, and our group is doing problem 817. What we're trying to do is we're trying to find the distance A where the supports at A and B should be placed so that the deflection at C will be equal to the deflection at, at the ends where the forces are acting upon. So we do the sum of forces and we find the shear diagram. And from the area underneath the shear diagram, we find the moment diagram. And because we have negative moment, we know that the deflection is going to be negative. It's going to be frowny face. All right, and from that, we use the moment area theorem. Uh, and then we know that the tangent at C is equal to 0. So we find the distance at A with respect to C and the distance at D with respect to C. And from there, Richie will take over to explain some more.
Hi, I'm Richie. So TAC is, just to get notation right, is the deflection of A with respect to C, and the same thing TDC, which is the deflection of D with respect to C. And then we have this other term, this third term here, which is just, we're just going to label it delta D. So to do TAC first, move over here, we're pretty much using this equation. Just means that we're going to take the area of the moment over EI diagram and then multiply it by x bar. So make it, so what you do is you do negative PA over EI, and what we're doing is taking the area of the square first. So the area of the square is going to be negative PA over EI times this distance right here, which ends up being L minus 2A. So we have negative PA over EI, L minus 2A over 2, because it's this distance divided by 2. And then for our x bar term, we're going to have L minus 2A divided by 4, because we want this distance right here, since we're taking the distance from A to the centroid of the square. So solving this, we get negative PA over 8EI times L minus 2A squared. Doing the same thing for TDC, we're going to have not only just the area of this square right here, but we have to also analyze the area of this triangle right here. So our first term is we're going to be looking at the square with respect to D. So the area is going to be the same. It's going to be negative PA over EI times L minus 2A divided by 2, which is the area. And then for our x bar, we're going to have, from D, we're going to have A plus L minus 2 over 4, because we want this distance plus this distance right there. So yeah, we have this term right here, and then and that's just for the square. And now moving on to the triangle, the area of that triangle is going to be 1/2 times negative PA over EI times this distance A, and then for x bar, we're going to have, just from known geometry, the centroid from D is going to be 2/3 A. So we have 1/2 negative PA over EI times A, and then x bar is 2A over 3. And then solving that, simplifying it, we're going to have negative PA over 24 EI times 3L squared minus 4A squared. And yeah, so for our final guest, we're going to have Sean Maloney.
Alright, so after all the information that we learned, we can finally equate delta D. From our diagram, that we can see that delta D is equal to TDC over minus TAC, absolute value of these lengths. So from that, we just plug in what we got earlier. We got our TDC right here. We got our TAC right here, and therefore we equate our delta D. And we're trying to find delta D, like we said earlier, so that delta D is equal to delta C. So delta D equal to TAC, because TAC is equal to delta C. And from there, we plug in our lengths that we got earlier, and we solve for A in terms of L, and therefore we get an answer of 0.152 times the length.